Hello and welcome. Artificial intelligence, AI for short, as all you know, has existed as a thing roughly 70 years. On this lecture I will briefly tell my own understanding of what has happened during these 70 years. And what will happen next, nobody knows. But I have a strong feeling that much of it will be connected to the topics that are considered on this course. British mathematician Alan Turing is considered to be the father of theoretical computer science and also the father of artificial intelligence. Already in 1950, he gave in his seminal paper titled Computing Machinery and Intelligence the idea that computing machines, computers, might someday become intelligent. In this same piece of work, he also proposed that, just like humans, machines might gain this intelligence by learning. Five years later, 1955, young and relatively unknown researcher John McCarthy from Dartmouth College, USA, coined the term artificial intelligence for this new form of machine intelligence. And a year later, 1956, this new branch of science was established in the now famous Dartmouth Conference. The idea of intelligent machines captured the imagination of researchers, leading to several overly optimistic predictions, intentional or not. While these grand visions of human-level AI were not achieved, at least the groundwork was laid for future breakthroughs. It took way over 50 years from its invention before AI finally started to work. And with work, I mean that it turned into billion-dollar businesses for technology giants like Microsoft, Google, Nvidia, or Facebook. It is generally agreed that the moment AI finally started to work was so-called AlexNet moment in 2012. This AlexNet moment was a pivotal event in the history of AI, specifically in the field of computer vision. A thing called convolutional neural network, CNN for short, called AlexNet, won the so-called ImageNet Large-Scale Visual Recognition Challenge, ILSVRC, with a top 5 error rate of 15.3%, a huge improvement over the previous state-of-the-art of 36.7%. This breakthrough led to a surge of interest in deep learning and the development of new and more powerful network architectures and new and more powerful computers to train those architectures. Developed around 2014, Generative Adversarial Networks, shortly GANs, once again revolutionized. The word is having an inflation. Revolutionized the ability of AI to create realistic images, videos, and even text. These GANs were one of the first examples of deep generative modeling, or alternatively generative deep learning. Reinforcement learning, RL, techniques made significant advancements too. AI agents learned complex behaviors through trial and error, achieving mastery in games like Go, StarCraft II, and Defense of the Ancients, Dota 2, which were previously thought to be beyond machine capabilities. And it was all not just games. Based on the same ideas, AlphaFold system learned how to fold three-dimensional proteins and got Nobel Prize this year. So-called transformer architecture for neural networks, introduced in 2017, improved dramatically natural language processing, NLP, tasks like machine translation and text summarization, offering new approach to processing not only text but all kinds of sequential data. GPT-4 represented a significant step forward in large language models, LLMs. Among other similar models, it offers impressive capabilities in text generation, translation, and computer code writing, programming. GPT-4 is perhaps not a major architectural breakthrough like AlexNet was. It builds on established techniques, refining them further. The greatest significance of GPT-4 and other LLMs is not necessarily within the field of AI research itself, but in the societal impact and public awareness of AI. Deep generative modeling tools like GPT-4 and Google Gemini, illustrated here, brought AI out of the research labs into the hands of everyday people. They made AI more relatable, concrete, and perhaps even understandable. This accessibility fuels public imagination about the possibility of human-level AI, artificial general intelligence, AGI. Because of this importance, I think it's fair to say that GPT-4 and its friends gave a similar boost to deep generative modeling, even if due different reasons, as AlexNet gave to deep learning. Deep generative modeling is having a big impact on the world. AI used to be based on retrieving existing, previously known information. The next generation AI is about generating new, unseen information. Let's summarize this discussion. 70 years of AI. 1950, Turing got the idea. 1956, McCarthy and others gave the name, created a new science. Lots of empty promises, lots of frustration, but lots of groundwork too. And after 50 years, AlexNet finally made AI work. Revolution in computer vision. ImageNet moment. And all this was possible because of deep learning. More data, more powerful computers, some better algorithms. And soon after these computer vision successes, we got also successes in natural language processing, NLP. And lots of other innovations followed, like GANs and reinforcement learning, transformers, you name it. But not necessarily such seismic shifts like AlexNet was, but remarkable improvements anyway. And then, just a year ago, GPT-4 gave us another ImageNet moment. We are now seriously thinking whether computers will be as wise or wiser than us humans. And whole governments and organizations have woke up. Do we need legislation for this powerful thing? How to keep control? And all this second seismic moment was result of deep generative modeling, the topic of our course. So, thank you. Meet you again.